Experimental environmental effect of anomalous behavior of water. Bodies of water such as lakes and ponds freeze at top point. As the lake cools toward 4 degrees Celsius, water near the surface becomes dense and it sinks. The water near the bottom rises. Once the colder water on top reaches temperature below 4 degrees Celsius, it becomes less dense and remain at the surface and freeze. If water did not have this property, lakes and ponds would freeze from the bottom up, which would destroy much of the animal and plant's life. Now, heat capacity. Heat capacity of a substance is the quantity of heat required to raise the temperature of a substance through 1 Kelvin. Heat capacity क्या होती है? कोई भी एक क्वांटिटी है, ठीक है, मटेरियल की, उसका हमें क्या करना है? टेम्परेचर रेज करना है, ठीक है। तो 1 केल्विन रेज करना है, कितनी हीट की रिक्वायरमेंट पड़ेगी? किसी भी बॉडी का टेम्परेचर 1 केल्विन इंक्रीज करने के लिए अमाउंट ऑफ हीट रिक्वायर्ड इज हीट कैपेसिटी, where delta Q is the amount of heat supplied to the substance to change the temperature from T to T plus delta T. Specific heat capacity. Specific heat capacity of a substance is the quantity of heat required to raise the temperature of unit mass through 1 Kelvin. देखो heat capacity is 1 Kelvin टेम्परेचर इंक्रीज करने के लिए हीट रिक्वायर. जब हम स्पेसिफिक बोल देंगे तो वी आर स्पेसिफाइड विद द सब्सटेंस 1 यूनिट मास सब्सटेंस को 1 केल्विन रेज करने के लिए कितनी हीट की रिक्वायरमेंट है. तो S is S by M. That is delta Q by M delta T. It depends on the nature of the substance and its temperature. SI unit of specific heat capacity is joule per kg per Kelvin, and the SI unit of heat capacity is gonna be just joule per Kelvin. ठीक है. Now smaller specific heat capacity. It is the amount of heat energy required to raise the temperature of one mole of a substance through 1 degree Celsius. That is 1 by mu delta Q by delta T. Molar specific heat at constant volume. Molar specific heat of gas at constant volume is the amount of heat required to raise the temperature of 1 mole of a gas through 1 Kelvin when its volume is kept constant. Molar specific heat of a gas at constant volume is the amount of heat required to raise the temperature of 1 mole of gas through 1 Kelvin at constant volume. Molar specific heat at constant pressure. Molar specific heat at constant pressure is defined as the amount of heat required to raise the temperature of 1 mole of gas through 1 Kelvin when temperature is kept constant. Next is calorimetry. Calorimetry means measurement of heat. When a body at higher temperature is brought in contact with another body at lower temperature, the heat lost by the hot body is equal to heat gained by the cooler body, provided no heat is allowed to escape to the surrounding. The device in which heat measurement can be made is called a calorimeter. It consists of a metallic vessel and stirrer of the same material like copper or aluminium. Change of state. A transition from one state to another state is called change of the state. Change of state and nature of transition. Whenever a substance changes from solid to liquid, it's called melting. Liquid to gas is known as vaporization. Liquid to solid is fusion. Solid to gas is sublimation without forming liquid direct. It's like camphor. Na? During change of state, two different states coexist in thermal equilibrium. See, whenever we provide temperature to something, either its state change or its temperature rises. Temperature time graph of ice. Melting point. The temperature at which solid and liquid coexist in thermal equilibrium with each other is called melting point. The melting point decreases with increase in pressure. The temperature at which liquid and vapor state of substance coexist in thermal equilibrium is called boiling point. The boiling point decreases with increase in pressure and it decreases with decrease in pressure. Increase with increase in pressure. Okay. Melting point decreases with increase in pressure, whereas boiling point increases with increase in pressure and decreases with decrease in pressure. Regulation. When a metal wire loaded at both ends is kept over an ice block, it passes through the ice block to the other side without splitting it. The melting point of ice just below the wire decreases due to increase in pressure. There is something controversial here. An ice melts water, wire passes and refreeze. This process, as ice melt, wire pass and refreeze due to decrease in pressure. This process is called regulation. Cooking is difficult at high altitude. Why? At high altitude, pressure is low. Boiling point decreases with decrease in pressure. Boiling point decreases with decrease in pressure. That's why it's difficult to cook at high altitude because pressure is low. So boiling point is also low. For cooking the rice, pressure cooker is preferred because the boiling point of water is increased by increasing pressure. We increase the pressure, its boiling point increase. You might have observed the bubble of steam coming from bottom of vessel when water is heated. These bubbles disappear as it reaches top of the liquid just before boiling, and they reach the surface at the time of boiling. Explain the reason. Just before boiling, the bottom of liquid will be warm and the top liquid will be cool. So the bubble of steam formed at bottom rises to cooler water and condense as they disappear. At the time of boiling, temperature of entire mass of water will be 100 degrees Celsius. Now the bubble reaches top and then escape. We had studied about specific heat. Now it's time for the latent heat. Latent heat is the amount of heat per unit mass transferred during change of state of substance is called latent heat of substance for the process. If mass m of a substance undergo a change from one state to other, then the quantity of heat required is given by Q is equal to ml. Latent heat is characteristic of substance and it depends upon pressure. Its unit is joule per kg. The latent heat for a solid liquid state change is called latent heat of fusion, and that for a liquid gas state change is called the latent heat of vaporization. See, we have a solid phase, melting point, then change of phase, then liquid phase, then phase change, then gas phase. जो सॉलिड में लिक्विड में गैस में था वो तो थी हमारे पास स्पेसिफिक हीट, ठीक है। और जब स्टेट चेंज हो रही है सॉलिड से लिक्विड या लिक्विड से गैस, वो हमारे पास है लेटेंट हीट. Burn from steam are usually more serious. Yeah, because steam contain more amount of heat energy na. N for water is 22.6. Heat is required convert 1 kg into steam. So at 100 degrees Celsius, steam carries 22.6 into 10 raised to power 5 joule more heat than water, as I said. Now heat transfer. Three methods: conduction, convection, and radiation. First is conduction. Conduction is the mechanism of transfer of heat between two adjacent parts of a body because of their temperature difference. The rate of flow of heat is proportional to temperature difference, and the area of cross-section A is inversely proportional to length. It is a kind of important formula for numericals. H is equal to Ka delta T by L, where L is length, delta T is temperature difference at two ends, A is area of cross-section, K is constant, and H is heat current, rate of flow of heat. The constant of proportionality is called the thermal conductivity of the material. The greater the value of K, the more rapidly will it conduct the heat. Thermal conductivity की वैल्यू जितनी ज़्यादा होगी उतना ही rapidly वो heat को conduct कर लेगा. Some cooking pots have copper coating on its bottom. Why? Because of high thermal conductivity of copper, it distributes heat over the bottom of a pot and fastly and promote uniform cooking. Now convention. Convention is the mode of heat transfer by actual motion of matter. It is possible only in fluid. Actual motion होता है convection में. It is possible only in fluids. Convection can be natural or forced. In natural convection, when fluid is heated, it expands and becomes less dense. Then it rises up and cooler water replaces it. This process goes on as a cycle. In forced convection, material is forced to move by pump or by other physical means. Some example are cooling system of automobile engine, heart that circulate blood throughout our body. Now sea breeze. We have two type of waves, sea breeze and land breeze. In one, the wind blow from land to sea, and in others sea to land. Let's see. Sea breeze. Wind from sea to land on daytime. During the day, the ground heat up more quickly than large bodies of the water. The air in contact with the warm ground is heated by conduction and expand, becoming less dense than the surrounding cooler air. As a result, the warm air and other air move to fill the space, creating a sea breeze near a large body of water. सी से लैंड की तरफ डे टाइम में आने वाली. नाउ लैंड ब्रिज, लैंड से सी पे रात को जाने वाली. At night, the ground loses its heat more quickly and the water surface is warmer than the land. There's a land bridges formed. See, water warmer than land, air current, night, land breeze. You have to just remember it, no? Sea breeze, wind from sea to land, daytime. Land breeze, wind from land to sea, nighttime. Daytime sea breeze and nighttime land breeze. Radiation. In radiation, energy is transferred in form of EM radiation called heat radiation. It requires no medium for heat transfer. Earth receives energy from sun by means of radiation. Thermal radiation. The electromagnetic radiation entitled by a body by virtue of its temperature is called thermal radiation. When this thermal radiation falls on other bodies, it partially reflects and partially absorbs. The amount of heat that a body can absorb by radiation depends on the color of the body. Black body absorb and emit radiation energy better than the bodies of lighter color. We wear white or light color cloth in summer so that they absorb the heat, least heat from the sun. During winter, we use dark color cloth which absorb heat from the sun and keep our body warm. The bottom of the utensil for cooking food are blackened so that they absorb maximum heat from the fire and give it to the vegetables to be cooked. Newton's law of cooling, that's much important. The rate of loss of heat, the rate of loss of heat is directly proportional to difference of temperature between the body and the surrounding. Greater the temperature difference between body and the surrounding, greater the heat it will lose. The loss of heat by radiation depend upon the nature of the surface of the body and the area of exposed surface, where K is positive constant depending upon the area and nature of the surface of the body. Curve showing cooling of hot water with time.